7.5 parametric equations. So the equation of a graph in two dimensions is said to be parametric in parametric form if each coordinate of your general point px is expressed in terms of a third variable. The third variable is denoted by a letter, and I didn't put that on there, t, and is called a parameter. So if your two functions f and g are continuous functions of t, then the set of ordered pairs f of t, g of t is on a plane curve. The equation x equals f of t and y equals g of t are parametric equations for c, and t is the parameter. So, for example, we can program a robot's path using a parameter. So to do this, we need two equations, one for the robot's x-coordinate and one for the robot's y. So think of it as a parametric as you're basically telling the position of the robot over a certain period of time. So therefore, you have to talk about its horizontal component and its vertical component at a certain point. So you could basically look and see where the robot is at 2 seconds, 3 seconds, 4 seconds, 5 seconds, if you think of t as time. So the equation for x describes the robot's east-west motion, and the equation for y describes the north-south motion. The two equations, x and y, are called parametric equations with a parameter of t. So you're basically checking their position at a certain period of time. Okay, example 1. So suppose the robot follows the path defined by x equals 2t, y equals t. So I'm basically going to plug in my values of t, 0, 1, 2, 3, 4, 5, into my x equals 2t equation. So 2 times 0 is 0, 2, 4, 6, 8, 10. All I did was substitute in my, let me get an arrow instead. All I did was substitute in my t values into my x equals 2t equation. Now I'm going to plug in those t values into the y equation. Let me change colors. And get my y values. Then I'm going to just plot these coordinates, the x and y coordinates. You don't need the t anymore. The t was already used as an influence to get your x and your y. Now you're going to plot these as coordinates. So you're plotting the point 0, 0, 2, 1, 4, 2, 6, 3, 8, 4, 10, 5. And as you plot the points, you're going to sketch the curve, otherwise known as a plane curve. You're going to indicate orientation. So meaning, as I plot these points, I'm going to put basically an arrow that's going to indicate if I'm starting at 0, basically then this is the next point, then this is the next one, because you're doing position. So at time 0, this is the first position. This is the next one, then the next one, the next one, and the next one, and the next one. So I'm going to plot, let me make this graph, oops, hold on, bigger. I'm going to draw on this and then shrink it back down. Hopefully it'll work. So we've got 0, 0. Let me double check and make sure that this will shrink back down. It will, okay. 0, 0, 2, 1, oops, 2, 1, 4, 2, 6, 3, 8, 4, let me move this around a little bit, 5, 6, 7, 8, 4, 10, 5. I might not be able to do that one up here. And so this is the direction that I'm going in. So you just have to put arrows on there to indicate the orientation. So I'm going to shrink, oops, let's leave that up. Let's shrink this one back down to fit back down in our picture. So then we can use substitution to rewrite our formula for x in terms of y. The path can be followed by the robot can be written. So I'm basically going to substitute one into the other. So if I have x, and usually when you write equations, you write y equals if you can. So I have x equals 2t. So if I want to kind of do substitution, I'm going to have to solve for t because that's what the two of them have in common. They have a t in common. So that's x over 2. So then I'm going to substitute this into my y equals equation to get y equals x over 2. So you've turned a set of parametric equations into what we call a rectangular equation. So we call this a rectangular equation, and we'll talk about that on another screen, rectangular equation. So this is what it looks like in parametric mode. And what parametrics allow you to do is it allows you to graph things that later on, like for instance, a parabola that's sideways, that's not a function. It allows you to graph that as opposed to the y equals where the calculator will only do functions. Okay, since the parameter of t can be easily eliminated from our equations, you may wonder why we should bother using them in the first place. One reason is that it can be useful to not only know where the robot is, but also when it gets there. Taken together, the values of x and y tell us where the robot is, while the parameter t tells us when it gets there. So for example, besides a robot, if we're talking about like two planes or a plane getting to a destination, if you're talking about two trains coming towards each other, how long it would be before they cross each other or they get there. Or if you've got two trains leaving at the same time, figuring out how long it takes one to get to a destination in the same amount of time it does the other. But we'll talk about robot paths right now. So example 2, suppose that we program the robot to follow the path defined by x equals square root of t, y equals 1 minus t, where t is the time in minutes. So in this case, since we have a square root, I'm only going to choose numbers, at least for t, for my basic equation, that don't require me to use a calculator. So I'm going to make my t values to be 0. I can find a square root of 1. I can find a square root of 4, 9, 16, 25. If I plug my values into that, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. Then I can plug them into y equals 1 minus t. 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 4 is negative 3, 1 minus 9 is negative 8, 1 minus 16 is negative 15, 1 minus 25 is negative 24. So those are going to be basically my y values for my coordinates. So I'm going to plot at least as much as I can, 0, 1, 1, 0, 2, negative 3, 3, negative 8, 4, negative 15. And I'm probably not going to have enough room to draw all of these because of the size of my graph. So we're just going to plot what we can, and we'll do that on the next screen. Okay, so from the last one, the only coordinates that I have that are going to fit in here are 0, 1, 1, 0, 2, negative 3, and I can probably get 3, negative 8 in. I probably am not going to get anything else in. So 0, 1, 1, 0, 2, negative 3. Let me expand this out a little, and then I'll come back to it later. 2, negative 3, 3, negative 8. So my graph is going to go like this. It's going to kind of be curved a little bit. Now let me squeeze it back down. Okay. So it should look a little bit smoother, but I was trying to do it on my graph. But indicate your orientation. So we call eliminating the parameter, combining them into one. So remember our two equations were x equals square root of t, y equals 1 minus t. So when possible, you want to get a y equals something equation, which means you have to solve the x for t. So my x equals square root of t. If I want to solve for t, I'm going to get rid of my square root. So my t equals x squared. And then that x squared will get substituted into this equation. So it's going to give me y equals 1 minus x squared. And that is the equation, the rectangular equation for my parametric graph. 3. Suppose we program the robot to follow a path defined by x equals t squared plus 5, y equals t over 2 plus 4, where t is time in minutes. So we're going to make a table of values again. So for t, I'll use 0, 1, 2, 3. We probably don't want to go any higher because the numbers are going to get bigger. If I plug them into this equation, 0 squared plus 5, 1 squared plus 5, 2 squared plus 5, 3 squared plus 5, I'm going to get 5. 1 plus 5 is 6. 4 plus 5 is 9. 9 plus 5 is 14. Then I'm going to plug it into this equation. 0 over 2 plus 4, 1 over 2 plus 4, 2 over 2 plus 4, 3 over 2 plus 4, which is going to give me 4, 4.5, 5, 5.5. Now I could keep going higher, but because my graphs usually only go to 10, probably you're just going to use the first 3 equations, and maybe that one we can just kind of add to it. So the points that I'm going to plot from the screen before are 5, 4. Remember, you're just doing x's and y's, not your t's. 6, 4.5, 9, 5, and maybe 14, 5.5. So I'm going to move this down for a second. Let's make this bigger for a second. Okay, we're going to move him down for a minute. Okay, I just made it bigger for a second so that I could graph him. So I'm going to graph 5, 4 as a point, 6, 4.5, 9, 5, and 14, 11, 12, 13, 14, 5.5. So my graph, let me make it a little thicker, is going to go like this. Okay, now let me squeeze it back down. Move this back up. Okay, so now if I want to eliminate the parameter, remember my 2 equations were x equals t squared plus 5, y equals t over 2 plus 4. So I need to solve this equation for t if I can. So x minus 5 equals t squared. So t equals plus or minus square root of x minus 5. And then I'm going to plug this in, into here. So my y equals plus or minus square root of x minus 5 over 2 plus 4. And that's going to give me my rectangular equation. Now keep in mind, in this particular case, we were talking about time, so you probably wouldn't do negative numbers. But t doesn't always necessarily have to be time. T is just the number for the parameter. In this case, we use t as minutes. So you can have a negative t value on here. So keep that in mind that right now we're just doing t as a positive number only because we're using t as minutes. Example 4. Suppose a robot follows the path by t, x equals t minus 1, y equals t plus 2. So again, let's do 0, 1, 2, 3, 4, 5, 6, 7, 8. If I plug t in, I'm going to get 1, 0, 1, 2, 3, 4, 5, 6, 7. Because you're doing 0 minus 1, 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1, etc. All the way up to 8 minus 1. Then for my t plus 2, you're just basically doing 0 plus 2, 1 plus 2, 2 plus 2, etc. all the way up. So that's going to give me 2, 3, 4, 5, 6, 7, 8, 9, that's an 8, 9, 10. So take a minute, copy those down. I'm going on to the next screen.